Welcome back again as we continue to study the fundamentals of advanced automatic process control. After successfully installing the cascade control system, the company once again looked at its raw material bill, and more specifically at component B. To ensure acceptable product quality, the pH of component B had to be within 0,1 of 6,3, and for this requirement, the company paid a premium. A cheaper version of component B was available, but its pH ranged between 6,2 and 6,7. The company decided to purchase the cheaper version and then balance the pH in-house. Here's how the process was planned. The pH of the incoming component could be easily measured. If the pH was above 6,3, an inexpensive acid could be added to the component until the pH was within the specification of 6,2 to 6,4. The control system the company chose to perform this process was a feed-forward controller. To understand the principle of feed-forward control, let's first review the basic feedback control system. The simple PID temperature controller is a good example of a feedback control system. You will remember that the desired temperature is entered by adjusting the set point on the controller. A temperature sensor attached to the output of the system informs the controller of the temperature of the mixture leaving the blender. The controller compares this signal with its reference signal and produces an error signal which adjusts the steam supply to maintain the temperature of the product at the desired set point. To summarize, feedback control takes corrective action only after a disturbance is detected in the process. Feed-forward control is the exact opposite. The disturbance is detected before it has a chance to affect the process, and the corrective action is taken before the disturbance upsets the process. Feed-forward control does have a limitation because it has no knowledge about the variable after the feed-forward process has been applied. We'll return to this point later. Having introduced the basic operating principles, let's see how feed-forward control was applied to component B. Raw material enters the plant with a pH in the range of 6,2 to 6,8. The process requires the pH to be between 6,2 and 6,4, so any pH value above the upper limit is considered to be a disturbance to the system, to which acid must be added. The pH and flow rate of the incoming component is measured by sensors placed in the pipeline. The pH and flow rate is read by the controller, which then calculates the correct amount of acid to be added to the component to maintain the pH at the desired value. Here's how the system worked in practice. When the pH was around 6,4, only a small amount of acid was required to lower it. But when the pH was 6,6, a much greater amount of acid was required to bring the pH to the desired value. When the pH was between 6,1 and 6,4, no acid was added to the component. The amount of acid to be added at any time was also dependent on the flow rate of the incoming component. When the flow rate changed, more or less acid was added.